Gravitation. The force of gravitation is considered a residual effect of the incompletely balanced electrodynamic forces between the elementary particles composing the electrically neutral material bodies. A normal material body is ultimately composed by electrons, protons, and neutrons. A body may be called electrically neutral when adding the electric charges of all its constituent elementary particles, the sum is zero. If all the charged elementary particles of a neutral body were at rest relative to the body itself, then the body would exert no net residual force on another external body, because the forces, given in this scenario by the Coulomb force, exerted by the charged particles of the first body on the charged particles of the second body would exactly cancel. But according to the model, the force between two charged particles also depends on the relative velocity of these particles, and therefore, considering that in normal matter the negative particles, electrons, have high speeds relative to the body itself, while the positive particles, protons, have small speeds, it is expected, as explained below, that the net electrodynamic force between two neutral pieces of matter is not zero. The model identifies such residual force as gravitation. And to be consistent with the fact that the neutrons of matter do also contribute to the gravitation force, it must be supposed that the neutron is also an association of a slow-moving proton and a fast-moving electron. As an example of a force between neutral bodies, consider the force between two hydrogen atoms at rest and placed at a distance d much bigger than the radius of the hydrogen atom. If an hydrogen atom consisted in a proton and an electron, both at rest relative to the atom itself, then, according to what has been said above, the force exerted by the proton on any distant charged particle p would be exactly cancelled by the force exerted by the electron on such particle p. But it has been shown in other sections of this work that the theoretical forces between elementary particles depend on the relative velocity of the particles. Therefore, it can be expected that the average force exerted by the high-speed electron of an hydrogen atom on a particle p is no longer exactly opposite to the force exerted by the proton on such particle p. A hydrogen atom will here be represented by a proton at rest and an orbiting electron of constant speed relative to the atom, and such that its velocity has the same probability to point in any direction of the three-dimensional space. The force that the atom number 1 exerts on the atom number 2 can be analyzed as the sum of four forces shown in the expression number 1, where F sub pp is the force exerted by the proton of the atom number 1 on the proton of the atom number 2. F sub pe is the average force exerted by the proton of the atom number 1 on the electron of the atom number 2. The average is over all directions of the velocity of the electron number 2. F sub ep is the average force exerted by the electron of the atom number 1 on the proton of the atom number 2. The average is over all directions of the velocity of the electron number 1. F sub ee is the average force exerted by the electron of the atom number 1 on the electron of the atom number 2. The average is over all directions of the velocities of both electrons 1 and 2. Naturally, the forces F sub pp and F sub ee are positive, meaning repulsion, while the forces F sub pe and F sub ep are negative, meaning attraction. The relation between those four forces can be guessed from the following considerations. Suppose for simplicity that the speed of the electron number 1 is equal to the speed of the electron number 2. Let W be the name of that common speed. Suppose, as said before, that the velocities of both electrons have equal probability to point in any direction of the 3D space. It is straightforward to calculate the following average relative speeds. The average speed W sub pp of the proton of atom number 2 relative to the proton of atom number 1 is of course 0, since the atoms have been supposed to be at rest. The average speed W sub pe of the randomly directed electron of atom number 2 relative to the rest proton of atom number 1 is of course equal to the speed W that has the electron number 2 in all its directional states, and therefore W sub pe is bigger than the relative speed W sub pp between the two protons. The average speed W sub ep of the proton of atom number 2 relative to the randomly directed electron's velocity of atom number 1 is again equal to W, and therefore equal to the average speed W sub pe of the earlier case. The average speed W sub ee of the randomly directed electron of atom number 2 relative to the randomly directed electron of atom number 1 happens to be greater than the speed W of both electrons. Since the force between two charged elementary particles decreases with their relative speed, as shown in two examples in the note number 1 below, it can be expected that the four forces between the particles of the two hydrogen atoms are related as shown in equation 2. And since F sub Pe and F sub Ep are negative forces, while F sub Pp and F sub Ee are positive forces, the net force that the atom number 1 exerts on the atom number 2 will be negative and therefore of attraction, if it also happens that the sum of the two negative forces is stronger than the sum of the two positive forces. It is plausible that this is the case as explained below. The thesis is therefore that the net force that the particles of an hydrogen atom exert on the particles of another is of attraction, and that this force can be interpreted as gravitation. Allowing now for the possibility that the speeds W sub 1 and W sub 2 of the two atomic electrons are different, the calculus of the average force exerted by the electron of the atom number 1 on the electron of the atom number 2 will rely on the supposition that each atom represents an average atom of a sample of atoms whose electron orbits are randomly oriented in space, and therefore both the velocity W sub 1 of electron number 1 and the velocity W sub 2 of electron number 2 have the same probability to point in any direction of the three-dimensional space. In this case, only the Cartesian component of the force between the atoms along the direction joining them needs to be evaluated, since the other two components will cancel by symmetry reasons. Let x be the direction joining both atoms, and suppose for simplicity that both atoms are at rest in the description reference frame. Figure 2 shows a possible velocity of the electron number 1 lying in the xy plane and forming an angle alpha sub 1 with the axis x. It also shows a possible velocity of the electron number 2 making an angle alpha sub 2 with the axis x, but with an azimuth angle equal to phi sub 2. Let F sub x be the x component of the force deduced from the model that an electron number 1 that is at all epochs in the position x sub 1 with the velocity W sub 1 exerts on another electron number 2 that is at all epochs in the position x sub 2 with the velocity W sub 2, and let the distance between the center of both atoms be also considered the distance between both electrons. The Annex A of the web page hosting the model gives the basics to calculate such force and other more generic forces between two elementary particles. The average value that will be called capital F sub x of the force F sub x when averaging for all the possible 3D directions of the velocities W sub 1 and W sub 2 takes the expression given in equation number 3 or equation number 4. Note that the azimuth angle phi sub 1 needs not be averaged due to symmetry reasons. The speeds W sub 1 and W sub 2 are supposed to be constant. But it happens that the expression of the x-component force F sub x deduced from the model does not depend on the azimuth angles of any of the interacting particles, and therefore the averaging of phi sub 2 in equation number 3 can also be omitted, giving the simpler expression number 4. In putting into equation 4 the function f sub x depending on the speeds of the two electrons would give the value of the average force F sub EE between those electrons. The other three forces participating in the total force between the two atoms can be treated as special cases of the force in which either the speed W sub 1 or W sub 2 or both are zero. Computer calculations have been made to evaluate the four forces and their sum, solving numerically the integrals of equation number 4. But due to the complexity of the expression of f sub x deduced from the model, and due also to lack of skills of the author in implementing the required precision of the results, no reliable results have been yet obtained. But other computer evaluations using simpler expressions of f sub x based on approximations of such force when the relative speed of the two interacting particles is much smaller than the speed of light show that the net force between the two atoms is negative, meaning attraction. Note number 1. In the video number 3 it was shown that according to the model, the force exerted by a charged particle A on a charged particle B that moves frontally relative to A, that is, that moves in the direction of AB with the speed u, behaves like shown in figure number 3. It can also be seen that when the speed u is much smaller than the speed of light, such frontal force can be approximated by the expression n3. And it was also shown that the component along the direction AB of the force exerted by a charged particle A on a charged particle B that moves transversally relative to A, that is, with a velocity u perpendicular to AB, behaves like shown in figure number 4. It can also be seen that when the transversal speed u is much more than the speed of light, such force along AB can be approximated by the expression n4. The gravitation force is implemented by heterogeneous, like all the forces of the model, and it could be said that it is only a special case applied to neutral bodies of the more basic electrodynamic forces between elementary particles. The gravitation force has a big similarity with the mainstream magnetic force between two neutral pieces of matter, since in both cases the internal velocities of some specific group of charged particles are the cause that the net electrodynamic force between those bodies is not zero. But the magnetic and the gravitation force have also important differences, since in the first case the electrons have a distribution of velocities that contribute to a non-zero net curl, while in the case of gravitation the electrons can be considered to be moving randomly in all directions, amounting to a zero curl. That is also the reason why the strength of the magnetic force between two neutral bodies depends strongly on the direction relative to some axis characteristic of the magnetic bodies, while the strength of the gravitation force does not depend on the mutual orientations of the bodies, since the gravitation force originated by normal bodies can be considered isotropic. The basic entities, sources and subject of the gravitation force are pairs formed by a slow proton and a fast electron that will be called p-pairs, and therefore the atoms are subject to the gravitation force, since they are formed by p-pairs with their protons in the nucleus and their electrons orbiting such nucleus. And so are the neutrons, that the model also considers a special type of p-pair, and of course the molecules that can be analyzed into p-pairs and macroscopic matter are also subject to the gravitation force. On the other hand, single elementary particles like a single proton or a single electron are not sources of the gravitation force, and therefore the concept of gravitational mass has no meaning for these elementary particles, although they can be assigned an inertial mass according to Newton's second law. For macroscopic neutral bodies, their gravitational mass will be very approximately proportional to their inertial mass, and physics can choose to make the constant of proportionality equal to 1. The p-pairs can be treated as a special type of elementary charge, in which the charges of normal matter are of the same type and always attract each other. But now the magnitudes of these elementary gravitation charges are not quantized, since they depend on the average speed of the electron of the pair that can vary widely. But an anti-atom of hydrogen made of a central antiproton orbited by a fast positron can be considered a gravitation charge of opposite sign to that of our normal p-pairs. Those anti-p-pairs would also attract each other, while an anti-p-pair would repel a normal p-pair. Normal macroscopic matter, like the one that constitutes the planets and the common stars, must be assumed to be highly transparent to the etherinos. Only a very small fraction of the etherinos entering the space assigned to the volume of a macroscopic body collides with its elementary particles and contributes to the gravitation force between those bodies. Such negligible screening of the etherinos by macroscopic matter is the reason that the inner atoms of those bodies also contribute to the gravitation force and hence to the gravitation mass assigned to those bodies. A possible way to classify the forces of the physical world would be: Group A, forces originated in other matter. In this group can be included the following three forces. 1. The force suffered by an elementary particle due to the presence of another elementary particle when the distance between the particles is much bigger than the size that can be assigned to the particles, and when the redistribution axes of the interacting particles are randomly oriented in space. This force would correspond to the electrodynamic force of mainstream physics. Note the conceptual split done by mainstream electromagnetism of the electrodynamic force into an electric force and a magnetic force is considered of interest just for practical purposes, but not from a fundamental point of view. 2. The force suffered by an elementary particle of anisotropous inner structure due to the presence of another anisotropous elementary particle when the particles are located very close to one another and when the redistribution axes of the interacting particles are specifically oriented in space. This force would correspond to the strong force of mainstream physics. 3. The net force between the elementary particles of the basic neutral entities, atoms, molecules, etc., in which the particles of matter normally associate. This force would correspond to the gravitation force of mainstream physics. Group B. Forces caused by the local ether itself. Note: the nature of the local ether, that is, its distribution of etheriness, is somehow conditioned by all the matter of the universe, but here it will be supposed that there is no near matter disrupting the standard distribution of etheriness of the local ether. In this group can be included the following two forces. 4. The ether drag force, due to the movement of the particles relative to the reference frame in which the local ether can be considered at rest. 5. The force exerted on the elementary particles by the random fluctuations of the ether. When these fluctuations act on some commonly stable association of elementary particles disrupting the association, this force would correspond to the weak force of mainstream physics. Notice that all the forces act on material particles and they are all implemented by the ether.